Hello everyone. Today we are going to see the one more part programming for the lathe operation. In this we are going to see the programming for the turning of the lathe machine, CNC lathe. Okay. So before starting that part programming, we are going to see once again the difference between NC machine and CNC machine. Okay. NC machine, NC stands for numerical control. CNC stands for computer numerical control. NC machine is controlled by the set of instructions in the form of numbers, letters and symbols, and the set of instruction is called as a program. And in CNC machine it is used to control the motion of the workpiece and tool with the help of prepared program in computer. The program is written in alphanumeric data. Okay, now in NC machine the programs are fed into the punched card, and in CNC machine the programs are fed directly into the computer by using a keyboard. Also, modification in the program is difficult in CNC machine, and whether the modification in the program of the CNC machine is very easy. As we know, in punch card it is difficult to modification, hence the modification is difficult in NC machine. And in CNC program you can modify the program. We have seen in our previous lecture that we can keep a gap between each blocks. So if we want, that means n01, n05, n010, n015, n020. So if we want the modification in between them, then we can insert that block in between these blocks. Okay, say if we want to do some operation after n15 sequence number, then we can give the number n15, after that n15, that is n16, then you can do the further process, that is n20 and n25 by following the sequence number. So in such a way the modification in the program is easy in CNC machine. In NC machine high skilled operator is required, and in CNC a less skilled operator is required. The cost of the machine of the the cost of the NC machine is less compared to the CNC, and the cost of the CNC machine is high compared with NC machine. And also the maintenance cost point of view, the maintenance cost is less of NC machine, and the maintenance cost is high in CNC machine. Now in CNC machine the programs cannot be stored. Okay, but in CNC machine the program can be stored in the computer and can be used again and again. So this is the main advantage of the CNC machine. And also NC machine offers less flexibility, where CNC machine offers additional flexibility. Okay, and let us see the accuracy point of view. Compared to the CNC machines, NC machine has less accuracy. Okay, and the CNC machine is having a high accuracy. Now let us see the execution of job point of view, that is the time required for the execution. In NC machine it requires more time for the execution of the job, and in CNC machine it requires less time for the execution of the job. And the last point, NC machine, that is it is not possible to run it continuously. NC machine cannot run continuously. Okay, so it is not possible. But CNC machine, it can be run continuously for 24 hours of a day. These are the advantages, and these are the differences between NC machine and CNC machine. Okay, now today we'll see our next program for the lathe operation, that is turning operation. Okay, so if you see here, you can see the step is given over here. So that is the 35 mm diameters bar is there, it is solid bar, and this two-step turning we are supposed to perform in this program. Okay, now let us see the program which is already made over here. Here it is the program, and the next one is the program with figure. Okay, so let us see the first slide, that is P1 is the program identification number, N05 sequence number, G54, G90, G71, G94. So G54 is nothing but a work coordinate offset. G90 it is for absolute positioning system. G71 for a stock removal in turning. G94 it is nothing but a feed per minute. Okay, so as I already said you that there are three major parts in part programming. First is program setup, second is chip removal, third is system shutdown. So we're in the first part. So after this we are going to move to the next block, that is we are going to give the spindle rotation and speed, and also we are going to, that is speed and its rotation. Okay, so here M06, M03, S1000. M06 is for a tool change. Okay, M06 for tool change, that is to select our tool, and M03 is for a spindle's clockwise direction movement, which is having a 1000 rpm. Okay, this is what the parameter we set, and this is what the initial, that is the first part, that is the program setup. Now we are going to move to the next part. Here next is N15 Z01 X minus 12.5 Z0 F2. Here we are going to do the facing of the job. Okay, so after facing this job we are going to retrieval the tool in next block, that is N10, sorry, N20 G00 Z1. Okay, see here the spindle direction is Z direction, so whatever this horizontal axis is there, it is a Z direction, and this is a X direction. Okay, now here we did the facing. Now we retrieved the tool over here. Okay, now next we are going to give some tool clearance, that is N25 G00 X000. Okay, now after this we are going to start the cut. Okay, so here you can see N30 Z01 Z minus 100, that means our tool is moving in horizontal direction. Okay, so cut is started, and after when cut the ends we are going to give a clearance position, that is you can see G00 X1 Z1. Okay, it is clearance position. Again we are going to take the position of the further cut, that is N. Here you can see N40 G00 X minus 2. Okay, that we have shifted little bit the tool ahead. Okay, now we are going to give the next cut. The length is having a 60. Okay, so here we will give a next cut, that is N45 G01 Z minus 60. Okay, the cut is given over here. Now again retrieving the tool. Okay, G00 G00 X minus 1 Z1. Okay, this is the retrieval of tool. Now we are going to give a position of a cut, that is N00 X minus 3. Okay, here x minus 3, and now again we are going to give a cut. Okay, that is z01 z minus 60. Okay, in such a way we are doing a turning operation over here. Okay, here you can see the 60 mm we have selected. So now after that we are going to retrieve the tool, that is x g00 x minus 2 z1. Okay, now again we are giving a position to the cut, that is g00 x minus 4. Okay, and after taking the position we are going to give the cut g01 z minus 60. This is the length we have given. Now again we are supposed to retrieve the tool. Okay, that is z00 x minus 3 z1. It is for retrieving of the tool. And again we are supposed to give position to a cut, that is n85 z00 x minus 4.5. Okay, so we are given the position. Now again we are going to perform a giving a cutting length, that is n90 z01 z minus 60. That is a cutting length. Okay, now we got the required diameter, that is diameter 16. Okay, so here our second part is completed out of 3, that is the G removal. Now we are going to move our third part. Okay, but before that we are, after cutting we are supposed to give a final position of tool, that is n95 z00 x5 z5. Okay, and after that we are going to use a M05. It is for spindle stop. Okay, as we have performed the chip removal, our turning operation is there. Now we are going to stop the spindle, that is our third part is there, system shutdown. We are, by using M05 we are going to stop the spindle, and at the end M02 we are using, that is for a program end. Okay, in such a way we can do a program for a turning operation. So now we are going to see the codes which we have used in this programming. P is for program identification number, N is for a sequence number, G54 it is for coordinate offset, G90 for absolute positioning system, G71 for stock removal in turning, G94 it is for feed per minute. Okay, and after that M03 it is for spindle clockwise rotation. Okay, having a speed 1000 rpm. Okay, and after that G00 is for rapid transfers, G01 for linear interpolation, and after that M05 is there, it is to for spindle stop, M02 is for the end of the program. Okay, so in such a way we can do the part programming for the lathe operation to perform the turning. Okay, that is part programming for the lathe operation. So here the axis is little bit changed, as we have seen in previous videos, that was for milling and drilling. Okay, while in milling part programming we were using the end mill cutter, and our cutter's position was vertical. Okay, so in that condition z axis was a vertical and the horizontal axis was a x axis, and vertical was a, the spindle axis was z axis, then horizontal axis was x axis, and the vertical was a y axis was there. That was in milling, and same for drilling also. In drilling we were using a drill bit, a vertical. Okay, So that was a z axis, and in the workpiece, if we see, its horizontal axis was x axis and its vertical axis was a y axis. But here, if you see, we used only the two axes, that is z axis and x axis. Okay, so here in this z axis is nothing but the whatever the spindle's axis is there, which is holding the job. Its axis is z axis, and the tool's movement, okay, the horizontal movement is a x axis. Sorry, horizontal movement is a z axis, and the giving the cutting depth of cut to the job, that was a x axis. And here we are not going to use y axis, because we are performing a turning operation over here, so y axis is negligible in this case.